Hello, everybody, and welcome back to Coffee Break, the show we break down interesting topics, all within the time it takes you to enjoy a few cups of coffee. As always, my name is Clifford Swartz, and today I am joined through the power of the internet by a very special guest, the one, the only, Chris Twigg. How are you, Chris?
Good. Thanks, Clifford. Glad to be with you here this morning.
I'm glad you're here too. So, Chris and I are going to talk about how all of us can get mad, but before we dive into that, I'm going to throw it over to Michael Pierce in the booth, and he's going to tell all of you how to participate. How you doing, Michael?
Great, thank you. So, welcome everybody, and we are live on LinkedIn, YouTube, Facebook, and we're definitely looking forward to this discussion this morning. It's a great tool. I've had a bit of a preview, and I wish I had this years ago. um, your questions. If you have questions, please submit them in your chat. And we have some experts online that might be able to answer straight away. And we will also ask questions after the presentation. Also, like us and share us. The more you like us and share us, the more people we can show these awesome products that we have. And if we don't get to your question, please email us at livestream@microchip.com, and we'll make sure we get back to you. Back to
Absolutely.
you, Clifford.
Thank you very much. So, first and foremost, MAD is a phenomenal acronym, but can you tell us a little bit more about what it actually is, Chris?
Sure, again. So MAD is our MPLAB Analog Designer, and it starts as a product selection tool. So it's basically geared toward making that analog design engineer's job a little easier in finding the right solution for their particular problem. So they start by entering in and selecting their application space. In this case, we're showing a general power management application. And below that, you can see there's a series of input design parameters and output conditions that they can specify.
Right.
And the first thing that they'll see is a list of options for what kind of solutions we have to provide, right? The next step is once they select a solution, it's also an online design tool. So it'll help try to guide them through selecting all of the components around the central part.
Cool. So once you go online, and I'm assuming this tool is totally free, right?
That's right.
Phenomenal. Well, once you're actually online and you set all your parameters, you find a circuit design that you like, where do people take it from there once they're ready to go beyond the web browsing tool?
Sure. So once you've configured it and gotten the design where you like it with the analytical solution from the web tool, it allows you to export and download this and use it within our MPLAB Mindy Analog Simulator environment. So now this gives you the possibility of simulating different conditions. You might want to change the loading conditions dynamically. You might want to do some transient input steps, anything that you want to add, or maybe add some more parasitics to the model you can do within this tool.
And so it seems to me like a phenomenal launching off point for any sort of design. For me, I wouldn't really know where to begin. I spent a lot of time reading, going through documents, trying to figure out a good place to begin, but this kind of seems like it sets you up ready to go.
That's the idea, is it's to give you a good starting point. And in a lot of cases, it's probably going to give you a solution that's going to just work.
Nice. So we've talked about the tool. Do you mind taking us through an actual demo of it? Is that okay?
Certainly.
Nice.
That takes us to our live demo.
Oh.
And for those, to make it easy, it's microchip.com/mad, which I have preloaded on my web browser. There we go. So now you can see a live demo. As I mentioned before, it's a kind of application-driven utility. So right now we have two applications. We are adding to that over time.
Cool.
But today we have power over Ethernet and general power management. So now let's say I've selected my general power management, and maybe I'll just choose a typical kind of automotive range for 9 to 16 volts. And I'm looking at a 5-volt output at, let's say, 1 amp.
Sure.
And I click the search button, and now it sends my request back to the server. You can see it spinning a little bit, so it's searching through all our list of solutions.
It's thinking. And there we go.
That's right. And then after a few seconds, it'll come back, and it gives you various categories that we support for that particular design parameter situation, okay? So in this case, it's given us a list of evaluation boards. And These are things that you can go to Microchip Direct and order today, for instance. So if you see this double check at the top, it says, hey, what you put in as a design parameter, we have a solution that matches that exactly today. You can
Nice.
go and order it and play with the hardware. If there's something in here that you're not really quite happy with, we have other options in a lot of cases. We might have reference designs, for instance. There weren't any in this particular search, but there could be in other search parameters. We also get these custom design generators. So now let's say we don't have a known good solution necessarily. We have the analytical tools that'll help you design a solution for your conditions. One other thing to point out, as you can see, that it is finding a lot of options. It's only displaying the first two, but you sometimes might want to narrow this down a little bit. So you might come over and slide some of these filter bars, for example, and kind of reduce that recommendation list down if you know some things. So for instance, if I wanted to have an automotive part, I might come over and check the automotive qualification button.
Makes
right?
sense.
And now it's going to reduce my list. Now you can see there's 3 evaluation boards and only 6 custom design generators.
So you mentioned that this was
So,
also a
what's
design
the next
tool. You mentioned that this
Yes,
was also a design.
exactly.
How do we design?
So how do we get to that point? So if you're starting with an eval board, you can actually just download the simulation files directly that I mentioned before, so that it'll work in the MPLAB Mindy analog simulator, or you can actually modify these designs a little bit, right? So it allows you to tweak these boards. It'll give you recommendations on like resistor network components that you can change to change the output voltage.
Right.
If you want a full custom design, you can come down and pick one of these devices, such as the MCP 16301. Click on that, and now you enter the design tool phase, okay? And here, it gives you a recommendation for all those component values around the main, chip there, the 16301, and we can go and we can modify some of these. So let's say, I want to change this output cap a little bit. Well, you click on it, you can come down, and some of these designs have fixed lists, like these regulators.
Right.
Some of them will let you do a freeform component value. So maybe I override this and I say, instead of the 20 microfarad that it recommended, I want to use 40 for whatever reason. I could come down and I can change, the feedback resistors and stuff like that. And you'll see here, I can type in a number. I can choose a constraint, whether I want it to be, an E96 series or equivalent to a 1% tolerant resistor. I can do a lot of constraint modifications there. What it notices is after I've overridden these values, I got to go back and recalculate some of the recommended values. So I click on the Analyze button, and it'll update all the other component values around the ones that I've changed.
Nice. That's pretty robust.
Yep. And so once you've got a solution there and you're happy with the component values, you can actually analyze things. A lot of ours will have a Bode plot, for instance, so you can check the stability criteria and look at how the circuit performs there. In some cases, we provide a little bit of efficiency guidance. Of course, this is making a lot of assumptions about the system and the board design and such. So it's guidance for doing comparisons between multiple designs, but it's not necessarily going to dictate what you're going to get as efficiency, just a ballpark.
So with this tool, I noticed that you're signed in, and I believe that's with your My Microchip. Is that required to use this tool?
So the initial search today doesn't require it, but once you get
Okay.
into the design tool, it does. And there's good reasons to do this. If I go and look at my design list, for instance, it keeps track of everything I've done on the site. So if I want to go back and revisit a topic or revisit a design that I've done in the past, it'll show up in this list. And if there's been an update to that design, you'll see a little exclamation point letting you know that, hey, we've made some changes. We might have improved something from what you did before.
Nice.
Okay. I should also have pointed out, you can go up and instead of using our default title, if you want to put something more meaningful in there for you and your application, you can actually override our default naming scheme. That way, when you go back through that list, you'll see something that stands out to you for your project.
Cool. So this is a fairly new tool. It's recently out of beta. Like you mentioned, you plan on adding more and more applications. How often is MAD updated?
Good question. So content is continuously added. I know we're only a part way through adding the entire Microchip analog portfolio. As I mentioned, we've only got the 2 categories today. We're adding many more application categories as we go. Parts are then basically entered, and a week or 2 go by of testing, and then we release them. right?
Nice.
User interface changes take a little bit more time. So we have a list and fairly regularly scheduled updates to the user interface. Some of those go live instantly. Some of them we try to bundle into new features that may be a little more extensive. And so those go out maybe once every month or 2 months.
That's still pretty frequent. That's impressive.
Quite often. We are definitely investing a lot of time and effort into this tool. Yep.
So currently, how many circuit designs or solutions are there on the MAD tool?
At the moment, there's a little over 100 solutions in
Nice.
there. So that's including custom design generators, reference designs, eval board links, and that sort of thing. Yep.
Cool.
And many hundreds to go, I'm sure.
Absolutely, as it should be. And so, like we mentioned a little bit earlier, once you're ready and happy with what you have on the web tool MAD, you can just export. And it's
Correct. So if you look in the top corner here, there's a little button that says export. You click on that, it'll pop up this little export window. If you do not have the MPLAB Mindy Analog Simulator, it provides a link so you can go and then download the tool. But over here, you can then download the exact schematic that reflects what the design generator put together for you.
nice.
So it's not just a template file, right? It has those actual component values. And you can, of course, rename it whatever you want.
Whatever's meaningful to you.
Mhm.
Cool.
That's right.
So, is there anything else you'd like to show us about the MAD tool before we move on to viewer questions?
I think that's pretty good. Like I said, this is a quick view. If you go back, there's these buttons for navigation. Let's say I wanted to go back and search, I wasn't happy with the 301 design that I was playing with. Maybe I can go pick another device,
Right.
6311 or whatever. If I want to go back and start all over, I can click the new solutions. So, these features keep getting added. I know we're going to keep adding new filters to it over the next couple of weeks. We're adding more product options that you can sort through and narrow down your selections. You can see in the front screen here, it shows you your previous designs. So when you're on this initial slide, you can actually go through and see your most recent designs. I didn't mention this before, but there is this select existing solution. So let's say you knew exactly what you wanted. You can do a search for, maybe it's a particular component. So maybe you're searching for the MCP 16311. You can put that in there and see what all solutions come up against that part.
Nice. Well, very
Yeah.
cool. Thank you very much. And Michael, if you're ready, what sort of viewer questions do we have for Chris?
Okay, we do have a couple of questions. One from Julio. Does this utility have the option to suggest part numbers?
Yes. So I showed you how it produces a recommended solutions list. If there are no solutions associated with it, it will default to a part recommendation. We want to try to give as much information as we can up front. So in addition to the solution, right, the part is embedded as part of that solution.
Nice.
Yep, and another one from Mike. How can I share the circuit with a colleague?
It's a good question. So today we allow the sharing of the search items. We are adding the capability to to share a specific circuit later. But right now, it'll work something similar to this. If I have a search string, for instance, I found the list of solutions that I want to send to somebody else, I can click on this share link at the top, and it'll provide a direct URL to this search list. What we will be adding in a future release is something similar. So when you're in a design, it'll have a share link at the top as well so that you can share this particular design. As a workaround for that today, obviously you can download the MPLAB Mindy simulation schematic and share that directly.
Right. Cool.
And another one from Raj. So how is it different from MPLAB Mindy? Can we say this is a superset of Mindy?
Not exactly. So Mindy is primarily a simulation environment, and this online tool today does nothing with simulation. It just provides the schematic guidance, if you will, that you can then run in the simulation environment. Mindy does have embedded with it a number of design generators, which we have translated to this web form. One thing I should point out is the design generators within the Mindy tool are relatively limited based upon the embedded web browser that's in the Mindy simulation tool. Here in the online environment, we can actually do a lot more powerful things, make better recommendations.
Yep.
They're meant to, I guess I could say, they're not a superset or a subset. It's really meant to work together
In tandem, yeah.
synergistically.
Okay. So, and one from Jared. While it's not relative to me, what about those who do not want to create an account due to privacy concerns or similar issues? So I guess they're asking if you can use it without having to log in.
Right. As it is today, you can do that initial search. So from the initial, selection screen here, you can do a search, and that you can do without a login. When you get to the point, though, of trying to use the design generators, it does unfortunately require a login today. I don't know if that'll change in the future or not.
So, are you able to use Mindy without producing a login, a MyMicrochip account?
As it stands today, you can download and use Mindy without a login. Yes.
So, theoretically, somebody could, I think, export. Is exporting behind a login or no?
It is.
Okay.
So, right. So to get to the design generator portion of it, yes, you have to have the login.
Yep. And we have another one. This is from Navadeep Ganesh. Can those exported schematics be directly taken into Eagle Pcb Designs, or probably other ones as well?
Right. I am not aware of a way to do that directly. No, today, unfortunately, a lot of the schematic formats don't really allow for migration to other tools. There are converter tools that try to do that, but I'm not aware of how well they work.
Right.
Basically, it would work today in the Mindy simulator tool itself. What we're looking at doing in future releases is adding some PCB support there. So for instance, you might be able to download the schematic in Altium. I don't think Eagle today is on our list of planned support, but that could change.
Cool. And even still, it's a phenomenal starting point. You still have the reference design there, and you're still better than just going through documents after documents trying to figure something out.
That's right.
What else you got for us, Michael?
Actually, something from me. I actually appreciate this tool because in the past, whenever I've done a board design using a switch mode power supply, I've had to go through the data sheet, find all the calculations. It takes 2 or 3 pages on a piece of paper to go through, and often I'll end up putting in a spreadsheet and doing it. It takes a lot of time.
Right.
Whereas this tool would have saved me several hours at least of going through and doing all the calculations and making sure I've got the right part selected and then double checking everything. So this is a really awesome tool.
Absolutely.
So,
Great.
and just one last scan. We'll see if we got one more.
Maybe.
Yeah, there is. Yep. Yeah. Someone just wants to know where this site is again. So,
Okay.
if we can repeat.
Microchip.com. Yep. Microchip.com/MAD.
Yep.
Nice and easy.
And that'll redirect you to the right place. That's
Phenomenal
right.
acronym.
So,
I love it.
Yep.
Well, cool. If that's all from our viewer questions, I guess I'll take it home.
I think that's probably good for now.
Cool.
Yeah.
Well,
And-
thank you very much. Oh, sorry, Mike.
Yeah, and for anyone that has additional questions, please email us and we'll get back to you.
We will make sure to send it over to Chris Twigg, and he will respond.
And that's live stream at microchip.com.
Yep. So thank you guys very much for watching. Thank you to everybody in front and behind of the camera. Chris, you're a rock star. Thank you very much for being on the show. We hope to see you guys soon. In 2 weeks, we'll be doing another coffee break, and that'll be showing you guys how to replace all the Hall effect sensors that you may have in your designs. But for now, stay happy, healthy, and I hope to see you in 2 weeks. Thank you very much.